Welcome back to the channel. Have you ever wondered if the universe is far stranger than we think? For decades, scientists assumed space-time was just a backdrop, a stage where matter and energy play their roles. But what if that assumption is wrong? What if space-time isn't passive, but alive, dynamic, and constantly shaping reality in ways we don't fully see? In this video, we'll explore why that assumption was made, whether it can actually become reality, and the mind-bending implications if space-time is more than we ever imagined. So buckle up, because this isn't just science. It's a shift in how we see existence itself. Have you ever wondered why an assumption is made? The idea that space and time form a static backdrop comes from classical physics. Newton described space as an absolute stage, infinite and unmoving, while time ticked away independently in the background. It was a useful simplification. It let scientists predict motion, forces, and planetary orbits with high precision. That assumption worked so well that it became the foundation of modern mechanics for centuries. But when Einstein came along, he broke that illusion. He showed that space and time are not independent. They're woven together into a fabric called space-time. And more importantly, this fabric can bend, curve, and ripple under the influence of mass and energy. The assumption of static space-time was replaced by a dynamic one, though many people still subconsciously think of the universe as an empty void with stuff floating around. Here's the twist. Even though Einstein already told us space-time is dynamic, we still wrestle with what that means. If the fabric of space-time moves, bends, and interacts, can we actually treat it like a thing in itself? Could it be that space-time isn't just a mathematical tool, but a real, tangible medium, something as real as the air we breathe, just invisible to us? The assumption can become reality if we prove that space-time has properties we can measure directly, like how gravitational waves ripple through it, or how quantum fluctuations might reveal deeper layers of this cosmic fabric. It's not a question of if, but when we gather enough data to confirm that space-time is as alive and interactive as anything else in the universe. Now, here's the mind-bender. What if dynamic space-time isn't just an assumption we're testing, but the actual truth of the universe? What if it's already happening all around us and we just don't recognize it? Imagine the ground beneath you shifting, not because of earthquakes, but because space-time itself is vibrating on scales too small or too large for us to notice. Our senses are limited. We see, hear, and feel only within a narrow window of perception. On a cosmic level, space-time could be bubbling, expanding, and folding in ways invisible to us. Just like fish in water don't feel the current unless it's strong, maybe we're blind to the subtle flows of the very medium we live inside, space-time itself. Is it possible that all this time we have been blinded by perception? The problem is scale. On the human level, space-time feels static. Your coffee cup doesn't warp reality, and walking down the street doesn't ripple the cosmos. But zoom out, or zoom in, and everything changes. Space-time is elastic, alive, and shaped by forces beyond our imagination. The challenge is bridging that gap between human perception and cosmic truth. So, how do we bridge that gap? By learning the language of the universe. Physics, math, and logic aren't just academic exercises. They are the grammar and syntax of existence itself. Just like we need language to communicate with each other, we need scientific language to communicate with the cosmos. Gravitational equations, quantum fields, and geometric models are all attempts to speak in the universe's tongue. If we can learn this language more fluently, we can decode deeper truths that might show us how to manipulate space-time, travel vast distances, or even understand consciousness as part of the same cosmic fabric. The universe is already talking. We just need to listen. If space-time is dynamic, alive, and deeply intertwined with everything we do, the implications are enormous. It means reality is not fixed, but fluid. Time itself might not be a straight line. It could bend, loop, or even break under the right conditions. Space might not be empty. It could be full of hidden energies waiting to be tapped. This also changes how we think about our place in the cosmos. We're not just tiny dots floating in nothingness. We're participants in a living, evolving structure. Understanding space-time could unlock new technologies, from warp drives to quantum communication, and even reshape how we see life, death, and the nature of existence itself. So here's the real question. If the universe is alive in ways we can't yet see, are we ready to face what that means? Space-time isn't just the background, it's the story itself, and we're characters written inside it. If this video blew your mind even a little bit, hit that like button, share it with a friend who loves deep questions, and subscribe for more explorations into the mysteries of the cosmos. And let me know in the comments, do you think space-time is just math, or is it a living reality?